Hey, Alexis.
I'll make it up.
Whoa! You have a privilege?
Yes.
Is it recording?
So yes, we are recording this lesson here at Northside Pride happening because I changed the handout in a couple of ways that I think will be beneficial for students, and I wanted the AB students to have this video. So Kathy, if you could just make sure that there's a little red light on all the time, and that we can see all the board.
Oops. Little red light.
There should be a... Okay, thank you for being there for me.
Oh, I see it.
Yep. All right, so let's get started, shall we? I remember maybe 2 weeks ago I told you by the end of this unit you were going to know like 18 different derivative rules or some crazy number like that. We have, sadly, 2 left. That's it. Now, that's not it in the world. That's it in terms of what you need to know. So let's start with the basics. Derivative of e to the x. Let's get some hands on this. Derivative of e to the x, Gabriel.
E to the x.
E to the x. All right, derivative of sine of x. Sine of x. Myra, derivative of sine of x. What's derivative of sine of x? Cosine of x. Look out, Stockensteiner. Okay, derivative of natural log of x. Josh. Loser. Okay, derivative of natural log of x. Annie.
1 over x.
1 over x. Derivative of e to the stuff. Like e to the f of x power. Oh boy. E to the f of x. E to the f of x. Go for it. Al.
E to the f of x times f prime of x.
Okay, right. The derivative of e to the f of x, it's e to the f of x times f prime of x. Al, what derivative rule did you just use to do that? This is a chain rule problem. You're taking the derivative of e to the power of, hear the word of, and you know chain rule. E to the power of stuff, e to the f of x times f prime of x. Okay, other ones. Derivative of 1 over x. See, Gustavo refuses to play this game. He knows all the derivative rules, but he will not raise his hand for a minute. He will not stoop to this level. Hey, Gustavo, what's the derivative of 1 over x?
Negative 1 over x squared.
Excellent. Derivative of 1 over x is negative 1 over x squared. Derivative of square root of x.
Of what?
Oh my god, again. Why? Brandon.
1 over 2 square root of x.
1 over 2 square roots of x.
No.
Oh, what a awkward. All right, derivative of x to the 6th power is, Carlos?
6x to the
Say 5. Yeah, 6x to the power of 5. I felt very prudent there. Now, that was too easy for you. What's the derivative of pi to the 6th power?
pi to the 6th power?
Yes. Don't fall for it.
I know, I'm right.
Don't fall for it. Derivative of pi to the 6th power. Derivative of x to the 6th power is 6x to the 5th.
6 times pi to...
Did you miss the part where I said don't fall for it? The derivative of pi to the 6th is...
0.
Why?
Because it's a number.
It's a constant.
Constant number.
Pi is a constant, so pi to this... I know, I just want to smack you in the head too. Alright, so we've got the product rule. Everybody, product rule says?
The derivative of the first times
Derivative
the
of the
second,
first
times the second
times the second
plus the derivative of the second times the first.
plus the derivative of the second times the first, or plus the first times the second, same thing. Quotient rule.
Low, high.
Low, high,
minus high,
low, all over, low, or for the French at home, low, high, minus high, low. That's how it works too. Sorry. Okay, whoever you are, sorry. Chain rule, f of g of x, the derivative there is going to be...
Dennis.
Wait, what?
What?
Chain rule, f of g of x, the derivative there?
The derivative of AB times the what happened?
The derivative of the long.
On the very
He's not 100% wrong.
Oh.
You're just in the neighborhood of wrong.
the derivative of the mama times g of x solo no baby and times the derivative of g of x.
Stop.
You know what? That gets you like a broken lace. If I only agree. That's
It's
a tough
broken
one.
like me.
All right. Chain rule, derivative of the mama. What I heard you say, Josh, was times g of x. No, son, no.
It's not.
Of.
Oh.
right? It's the derivative of the mama, leave her baby alone, times the derivative of the baby, we're okay? These are like, I would say like the basics. Now, we want to get nasty. Derivative of tangent of x. Derivative of tangent of x. One person, 2, 3. Derivative of tangent of x.
I got this one.
Patient.
Secant squared x.
Secant squared of x. Okay, nice. Derivative of secant squared of x here. Ah, that's the pen marker. Here. It's like going to the circus. All right. And let's see. Derivative of arc tan of x. If you can do it without looking at your notes. You got it? What's got for me?
1 over x squared minus 1.
Oh, no. Oh, so.
Oh, minus x.
Oh, no. If people are trying to help you, Gabriel, help out.
1 over x squared plus 1.
1 over x squared plus 1 or 1 over 1 plus x squared. It was close. It was close. Here. Otherwise you'd be sat puppy all day. All right, we've got all these derivative rules. We've got them. We've proven a lot of them. We're ready to go. Do we still have a red light over here? I'm so used to Steven at Southwest, who takes good care of me, and we call him Steven Spielberg because he does such a good job. All right, we've got 2 new derivative rules coming your way, and this is going to be a push. I just want you to know we're going for extra innings here. Derivatives for inverse trig functions used to be something that was only ever assessed on the calculus BC exam. That is no longer the case. You guys now live in a world where on the calculus AB exam, these might come your way. Now here's the good news. We're going to spend the next 15 minutes proving some of these things. I am not ever going to assess you on the proof. I promise you that is not the direction that we're going to go. If at the end of this day you're like, I just need to memorize these last 2 derivative rules, that's fine. So sad. And it drops. All right, so here's what we got. I want to do a quick review of some pre-calc stuff. We've got the graph of the sine of x over here. The goal here is to come up with the derivative for the arc sine function, or the inverse sine function. And we're going to run into a problem. Because I want to find the derivative for the inverse sine. Unlike sine function, which I know you guys know really, really well, I bet the derivative of the graph of arc sine is not one that is known well in the group. Is that fair to say? Could we all find it on the calculator if we needed to? Okay, so here's the thing. The thing I need you to remember about a function, so this is like f of x, and this guy down here is the inverse. We've got this neat relationship between a function and its inverse. We know that if there's a point like this guy over here, 0, 0, on the original function, then there's a corresponding point on the inverse function, which is 0, 0. But we're kind of like switching the x's and the y's there. And so maybe you don't see it. Well, let's try some other points. On the sine function, for example, up here, what are the coordinates at this point here?
Pi over
pi over
2,
2, 1.
Pi over 2, 1. And hopefully that makes sense. Sine of pi over 2 is 1. Come over to the inverse graph. That point is no longer pi over 2, 1. On the inverse,
1 over
it should be 1.
pi over 2.
On your graph, is this pi over 2 up here?
Yes.
Like
No,
this
no,
top
no.
one?
The one in the
The
middle.
second
The one in the middle.
This one?
Yeah.
Okay, so the point 1 comma pi over 2. Now we can do this for a long time. We can say, okay, well here's the point, negative pi over 2, negative 1. On the inverse, negative 1, negative pi over 2. I could take a point like, what is this guy over here? Is this pi over 4? And it would have to be square root of 2 over 2 if it's on the sine graph. Which means on the inverse, I go to square root of 2 over 2, and you may be like, well, what is square root of 2 over 2? Square root of 2 over 2? Is it decimal? It's not 2, it's somewhere between 0 and 1, and if you want to get it on your calculator, feel free. Square root of 2 is 1.4 and some change. So square root of 2 over 2 should be like 0.707.
0.707.
So if I'm going to plot that point, 0.707, and then go up, so this is like square root of 2 over 2 comma pi over 4. And if you were to just graph this, right, if you plotted all the points, you're going to get a graph that looks something like that. That's the graph of arc sine. And you might think, but wait a second, all that we did is we picked a couple of points, and aren't there other points? Aren't there points on the curve, like for example, what are the coordinates here? The second root. Careful, not
Pi
0,
zero.
pi.
Pi zero.
This would be pi 0. What happens on the inverse? 0 pi. There's other points that I might want to consider, like this guy over here is 2 pi comma 0. On the inverse, that would mean that there's a point up here, 0 comma 2 pi. I would hope at some point you start to become uncomfortable with this idea. Because what happens is your inverse sine graph would have to pass through all of these points, going all the way up and going all the way down. And this is hopefully making all 15 of you uncomfortable right now. Why? Let's get some hands on this. What's wrong with this? Where's the uncomfortableness coming from? Aisha, what's uncomfortable for you?
This is not a function.
This is not a function. How do you know this is not a function?
It doesn't pass the vertical line.
This fails the vertical line test more than anything else. So what happens with the arc sine graph, we actually start talking about putting on domain restrictions to the original function. And the domain restrictions that we agree on as a math community is from negative pi over 2 to pi over 2. Which means on my graph, I'm only going to consider range values between negative pi over 2 and pi over 2. I'm not going to go below there, and I'm not going to go above there. And what happens is this is still a function. But the only way to come up with a inverse for the sine is to consider a restricted domain. There was no calculus that just happened there. There was a little bit of algebra, and a little bit of trig. Is everybody okay? All right, so good, thank you. All right, so here's what I'm really interested in now. Based on all the things that you know, what must be true about the graph of the derivative? Conversations are going to sound like the ones we've had before. What's this function doing? What does it tell you about the graph of the derivative? Okay, have a conversation, give me some notes. I want to know, like, what happens over here? What does it tell me about the derivative? Go and we'll talk.
You're so far away from
Give me one thing you know about this function and what it tells you about the derivative.
maybe like in general, like negative, positive, stuff like that.
So it's something like the
Think about function and its derivative. What do you know for sure?
But derivative, but
Isn't it always increasing?
This is the function, this is what you see in front of you. What does that mean about the derivative? Why? Right. Give me some evidence here. And what does it tell you down here?
no, since it's
yeah, the
There's
derivative.
no concave right, concave left. There's concave
Or
left.
down with concave.
But I understand.
So sort of like
If it's concave down, then that means,
like a
Okay, which function are we talking about, right? This is where things get confusing. We've got an original function, its inverse, and now the derivative. So don't say it. So this function is increasing? Yes. So what do you know down here?
it's positive.
Has to be positive, right? This is the conversation.
Well, then, maybe that's right.
all those right?
All right, let's pull everybody together. Things that you know about the graph of arc sine and what it tells you about the derivative. Let's get some hands on this. Anything that you know over here and what it tells you down here. Alexis, what do you got?
The inverse is increasing.
The inverse is increasing.
So the derivative is positive.
Okay, arc sine is increasing, but here's where you're going to be careful. Increasing where? Where is this function increasing? From where to where?
Negative negative pi over 2 to
Not negative pi over 2 to pi over 2.
Wait,
If this
one,
function's
one.
increasing, I want x value, so we're increasing on the interval negative 1 to 1. So if arc sine is increasing, the derivative has to be positive. Okay, so this guy has to be positive for the interval negative 1, 1. There's a couple more things that I'm hoping to get out of you guys. What else? Again, Brandon.
There's a saddle point at 0, 0.
Okay, maybe there is a saddle point at 0, 0. Maybe. But there's something really special that's happening at 0, 0. Something is changing at 0, 0. Myra, do you know what's changing? The concavity is changing. What kind of concavity over here?
Concave down.
Okay, we've got concave down on the interval, what is that, negative 1 to 0? Which means that this guy down here, we've got concave down on the inverse graph, so the derivative graph has to be decreasing. So decreasing for the interval negative 1 to 0. Conversely, this guy over here is concave up. So if this guy is concave up, then this guy over here, increasing. Okay, so concave up on the interval 0, 1. So over here we are increasing for the interval 0, 1. Now there is something special happening at negative 1 and positive 1, and I'm curious if anybody knows what that is and why that is. There is something very specific happening at these points. At negative 1, negative pi, and positive, whoa. Negative 1, negative pi? This is
Negative pi.
negative pi over 2. Negative 1, negative pi over 2, and positive 1 pi over 2. There's something very, very specific happening. Do you know what's happening? Horizontal asymptote. A horizontal asymptote would mean like the graph is like decreasing or increasing and getting flatter. There's something very special happening at negative 1, negative pi over 2. And it might be easier to think about what's happening on the original function. Where does this point come from? Negative 1, negative pi over 2 comes from this point over here, which has a horizontal tangent line. And on the inverse, not a horizontal tangent line.
Vertical.
There's a vertical tangent line here. They're way hard to see. Over here, they're hopefully a little bit more obvious.
That's what I'm imagining happening.
That's, okay. All right, so we've got a vertical tangent at x equals negative 1 and at x equals 1. So the thing that you need to know down here, vertical asymptote. So vertical asymptote at x equals negative 1 and x equals positive 1. So I've got vertical asymptotes at negative 1 and at positive 1. What else do we know? Always positive, so always above the x-axis. Decreasing from negative 1 to 0. Increasing from 0 to 1. I have to be above the x-axis. I have to obey the rules of my vertical asymptotes. The graph's going to have to look something like that. It looks like me because it's wide and flat. Oh, a U. I thought you said it looked like you. And then I thought, well, there's somebody who's not going to make it to senior year. Okay, now here's the thing. This is what the graph should look like. This is not a parent function. I would not expect anybody in the room, myself included and Ms. Stuckenschneider, to be like, oh, I know what graph that is. You don't. What I do care about is this. Are we feeling good about this review from like sine function to inverse sine? We're okay? Going from this guy here to what the derivative has to look like? All right, so here comes the last big push. I want to prove what this derivative rule has to be. This is going to be the part that might be a little bit uncomfortable. And I want you to have your calculator handy. We're going to do a proof. It's going to feel a lot like the one that we just did on By just did, I mean Thursday. All right, so here's the proof. What I want to do is I want to come up with an expression for the derivative of arc sine of x. We're going to get there. Danny, you okay? Oh, you're getting the calculator. All right, so here's the thing. I know that this guy here is what I'm going to call g of x, is my arc sine. I don't know what the derivative is, but the good news, I know what its inverse is. Its inverse is a friendly function that you work with all the time. The inverse of arc sine?
1 over x.
That's derivative of arc tan. The inverse, what function has arc sine as its inverse?
Sine.
Sine. So if g is arc sine and f of x is sine of x, what I know is that f of x and g of x are inverses. And because f of x and g of x are inverses, there's another derivative rule that you know. This is what we did on Thursday.
Isn't it that g prime equals 1 over
When f and g are inverses, g prime is 1 over
f prime of g of x?
f prime of g of x. G prime is 1 over f prime of g of x. This is where we were Thursday. Okay? G is the arc sine function that I'm trying to figure out. I don't know how to take a derivative of it yet, but I know that f is sine of x is the inverse. So let's use this derivative relationship. The derivative of arc sine then has to be, well, what's the derivative of arc sine going to be? The derivative of arc sine is 1 over f prime of arc sine of x. And you might think, gosh, that doesn't help at all. But in order to figure this out, I need to know, well, what's f prime? G is the arc sine. F is the sine of x. So f prime has to be cosine. So our derivative, whatever the heck it is 1 over the cosine of the arc sine of x. And that might look ugly and tough to memorize, and gosh, what does that really mean? The secret to unraveling all this is to go back to trig. And when we talk about arc sine, what I'm really asking you is for an angle. I'm saying, like, this guy here is an angle, but it's a special angle. It's the angle that when I take the sine of that angle, I get x. Remember, I'm not ever going to assess you guys in the proof. I want to take you through the proof so you've seen it and have somewhat of an appreciation. Well, if sine of theta is equal to x, I can make a little right triangle here. When I make my right triangle, what's really important is that if that's what I'm calling theta, I need to label these sides so that the sine of theta is x. How do I get sine of theta on a right triangle? Sine of theta is opposite over the hypotenuse. So the opposite is x and the hypotenuse is 1. So this triangle over here is just my reference triangle. What I need, though, is not the angle, but the cosine of the angle. Where does cosine of an angle come from? The cosine is adjacent over the hypotenuse. You know that the opposite is x. You know the hypotenuse is 1. You know something called the Pythagorean theorem that says that whatever this guy, apparently this is a day for me to knock all the markers off. Whatever this guy is here, question mark squared plus x squared equals 1 squared. That's your Pythagorean theorem. So the side that I'm looking for, how long is that? Subtract x squared to the other side. Take a square root. So how long is this side here? It's square root of 1 minus x squared. So what that means is this derivative that we're after is equal to 1 over cosine of theta. But I've got my right triangle, and you guys can tell me that the cosine of theta is adjacent over the hypotenuse. So your derivative has to be 1 over the square root of 1 minus x squared. This is the derivative. Derivative of arc sine is 1 over the square root of 1 minus x squared. For those of you that are like, is this the thing that I have to memorize? Yes, this is the thing. Okay? If the proof went over your head, don't let it freak you out. Now, we don't have the time to go through and do this again for arc cosine, so I'm going to cheat a little bit. Just a little bit. And I'm not sure if Ms. Stuckenschneider would be up for this, but at Southwest, I was going to offer an opportunity for students to have their lowest homework assignment grade replaced with a better one if they went through the similar process, if you flip over to the next page, with cosine and coming up with the derivative of arc cosine. It is going to be a very similar process from start to finish. The answer in the end is going to be a little bit different. Ms. Stuckenschneider, are you okay with that? Mm-hmm. Right, and all I said was replace your lowest homework grade with a better one. So if you really tick her off and you're like, I had a 50 and here's what I did, and she'll be like, great, here's a 51. That's a better grade.
Not too.
Okay? So be kind to her. All right, so let's pull this all together so you guys can just see it and use it. And I'm going to try not to trip over all these markers I keep knocking to the ground. And if you flip over to this next page in the handout, I'm just going to tell you what the derivative rules are. Okay, here we go. Derivative of arc sine. You guys know derivative of arc sine?
1 over x squared plus 1.
Oh my gosh, Edgar. Check your notes, son. Derivative of arc sine of x. 1 over square root of 1 minus x squared. Now here's the thing. That is the derivative for arc sine of x. That's not what I'm asking for over here. I'm asking for the derivative of arc sine of f of x.
Whoa.
So you know what I need here.
Chain rule.
I need a chain rule. Chain rule says take the derivative of the mama, but leave her baby alone. So instead of 1 over the square root of 1 minus f of x squared, I'm sorry, instead of 1 over the square root of 1 minus x squared, 1 over the square root of 1 minus f of x squared. That wouldn't be complete. That's not what the chain rule would tell me to do.
The derivative.
Derivative of the baby. You take the derivative of the mama, leave her baby alone, times the derivative of the baby. The derivative for arc tan of x, that will give you like a little side work here. Derivative of arc tan, what is that? That's 1 over x squared plus 1, so the derivative of arc tan of f of x. 1 over f of x, the whole thing squared, plus 1, times the derivative of f of x. It's just chain rule. Just chain rule. So the last piece, and I know I haven't like officially told you guys this, here's the really beautiful thing. The derivative of arc cosine is the opposite of the derivative of arc sine. It just is. When you go through and you do the proof, you're going to see it. So the only difference between these two, derivative of arc cosine has a negative in front of it. So it'll be negative square root 1 minus f of x, the whole thing squared, times f prime of x. When you go through the proof, you're going to see the negative. You're going to see that negative show up. That's the only difference between the two. But you'll figure it out. All right, based on that, let's see what you guys can do with this first one. I want you to find derivative of arc sine of e to the 3x. And I think you can do this without my telling you much of anything. That's the thing you have to do is alone cosine of
The spirit. That's the spirit.
Angela, can you read that first one to me? What is it that we're trying to find the derivative of?
Arc sine of
Arc sine of
e to 3x.
e to the 3x power.
Yeah.
I was hoping you might read it a different way. E to the 3x power is one way to say it, but the other way to say this, it's e to the power of 3x.
Yeah.
So guess what? 2 channels. What was that noise? Okay, so maybe you want to like just, especially in the beginning, like make a little note on the side. Okay, I know derivative of arc sine of x is 1 over the square root of 1 minus x squared. I know that one. But what's the derivative of arc sine of stuff? It's going to be 1 over square root 1 minus the stuff squared. Don't stop.
Times.
E to
And depending on your comfort, right, you might say, hey, you know what, I'm just happy right now that I got the form, and I'm going to come back and take care of this on my next pass. Just use that EDX notation to be like, okay, I'm going to come back. Now I just have to figure out what's the derivative of e to the 3x. Derivative of e to the power of stuff is e to the stuff times derivative of the stuff. When I put it all together, I'm going to have 1 over the square root of 1 minus e to the 3x squared times e to the 3x times 3. How many guys honestly had that as your derivative? Nice. You needed one new derivative rule, and then it just fits nicely in your bag with all the other things. Now, one small thing. Free response, this is a great answer. Multiple choice, I'm going to hide this from you. You know I'm going to hide this from you. I do it all the time. How could I go about hiding this from you? Gabriel sees it. It's not calculus that's going to hide this answer from you. It's algebra. There's some algebra stuff I can do here to keep this answer from you. Gabriel, what do you see?
You can multiply it and like the e of 3 of x times 3 goes on the top.
So the e to the 3x times the 3, I can put it up in the numerator?
Yeah.
Okay. So you might say, great, 3e to the 3x over the square root of 1 minus e to the 3x, the whole thing squared? That's not the answer you're going to see in the multiple choice. If I'm going to hide it, I am really going to hide this deep. There's something else. It's an algebra 1 / algebra 2 thing. It's not a calculus thing that I'm going to do. Carlos, what do you see?
Instead of the square,
What about that square?
plug it in, well, you're gonna have to multiply it.
So e to the 3x, square that. Means e to the 3x times e to the 3x. What's the rule there?
Product rule.
Whoa, hold on. You guys are saying product rule. I'm asking what's e to the 3x squared? E to the 3x times e to the 3x, bases are the same. Add the exponent so it becomes e to the 6x. Or if you're thinking like power rule, like you multiply these two together, that works too. Either way, it's going to be 3e to the 3x over the square root of 1 minus e to the 6x. I cannot think of a good way to simplify it further than that, but know that that could happen. Gabriel, you okay? All right, so what you guys can do with the next one. Have fun.
Is that a multiply?
If I was trying to solve it organically, yes. That's not what I'm trying to do.
The square root of x?
Yeah. Trust the instincts. One smart cookie sitting up front. There's others. Go back to take that.
Plug it in. Then you plug in the square root of x.
Ah, beautiful stuff.
Read the one.
Thank you. So the derivative of first times second times the first times the first.
Nice. Oh, such a proud papa. I had debated whether I was going to be kind. I'm so glad I decided not to be kind. Here's what kind looked like, Kathy. I was going to put a little dot in there to make it really clear that this is a multiplication problem. Most people are okay?
Yeah.
There was another thing I was going to do to be kind. I was going to use parentheses over here to make it really clear that I needed chain rule. Okay, I would say the derivative here is a 2-point derivative. So let's see how many of you guys would have earned 2 points. F prime x times arctan, you guys know we need product rule. So derivative of the first, leave the second one alone, plus now it's the first, and we've got to take the derivative of arctan. And even though I have taught calculus since like Newton was in school, okay, I'm going to write this as derivative of arctan of the square root of x, because quite honestly, I'm not ready in the middle of product rule to think about this. If you got there, 1 point. Now the work shows up. What's the derivative of arctan of the square root of x? That's going to have to be 1 over square root of x, the whole thing squared, plus 1. Don't stop. Times derivative of the square root of x. If only you had a teacher that was telling you all the time, memorize the derivative of the square root of x, you guys would all be able to tell me
1 over 2.
1 over 2 radical x. So your derivative, f prime of x, is arc tan square root of x plus x times all that stuff. And I would not worry about simplifying, but I would also hope that you all realize you're not done. Now you got to plug in 1. So be careful. F prime of 1. Arc tan square root of 1. 1 plus 1 times 1 over square root of 1 is 1 squared 1 plus 1 is 2 times 1 over 2 square roots of 1 is 1, so 1/2. That's a great answer. There is no need to simplify if you're on the free response. But I will tell you, I need you to know this part. I need you to know what arctan of 1 is.
Is 4?
And it's pi over 4. Nice. Angela, why is it pi over 4?
Because pi over 4, tan of pi over 4 equals 1.
Okay, tan of pi over 4 is 1. Right, when you say arctan of 1, go back to like the way we were translating it before. You're saying the tangent of what angle do I know of is equal to 1? Tangent of what angle is equal to 1? Pi over 4. So this first part is pi over 4 plus 1 times 1/2 times 1/2, and I hope everybody's okay, that's just going to be pi over 4 plus 1/4. Okay. A little bit of some ugly trig happening in the middle of the calculus. Hope and pray that a problem like this, if it's going to show up, shows up on the free response. And if that happens, arctan of 1 is your answer. If you're not comfortable figuring out pi over 4, well, just sacrifice a small chicken. Hope that this doesn't show up in the multiple choice. Did I just say sacrifice a small chicken? Okay, a big chicken. Okay, make it worthwhile. All right, go for the next one. See what you can do.
Oh, we have to find an equation.
Just going to keep coming back. Find the point, find the slope, find the equation of the tangent line. So what are you thinking this is? They're not. I'm not saying that arc cosine equals this. The derivative of arc cosine would be. You haven't found a derivative.
Cosine
What's the plan, son? What are we doing? Okay, that, hopefully, tell me why you're doing that. What is it that you read in this problem that says, hey, I should be finding this derivative?
That would be 2x.
That's not what you read. That there, just seeing arc cosine of 2x does not tell me to go and take a derivative. There is a reason you're finding a derivative here. You want the equation of the tangent. What do you need in order to get the equation of the tangent? You need the slope and a point. That is that slope, that like I need slope, right? Because you need slope, you have to find it. It couldn't be one. None of these things. Angela, is there still a red light on there?
Yes.
Okay.
I think the track is lower too because
I'm so used to Steven handling all the filming, he just does it all. Except like today when he screwed it up. What's a Steven? It's another student.
it's a camera.
Oh, I thought it was a piece of like technology or computer.
Yes, it's a Steven.
Yes, Steven.
Actually, with the amount of time he spends Googling advanced calculus stuff, he could be a robot, I'm not sure.
I'm gonna still lose that was his brain.
Alright. So, let's plug it back together. So I know from walking around, equation of a tangent line, everybody knows I need a point and a slope. Just have to have these things. So I need a point, I need the slope. So in order to get the point, that means you have to find f of square root of 3 over 4. So that's the arc cosine of 2 times the square root of 3 over 4, and now I'm being mean. 2 times square root of 3 over 4 is the square root of 3 over 2. Maybe that's not too mean. Now here comes the tough stuff. What's the arc cosine of the square root of 3 over 2?
5
Dang. Okay. And for everybody else watching this video, they're like, what? Arc cosine of square root of 3 over 2, cosine of what is equal to square root of 3 over 2? Even though I've taught calc forever, I always have to kind of go on the side here. That's square root of 3 over 2. That means that's a half. What's this angle? 30 degrees, so it's pi over 6. Arc cosine square root of 3 over 2, pi over 6. That's the point. Now I need the derivative, and I'm really interested to see how many folks get this. The derivative of arc cosine of 2x negative 1 over square root 1 minus 2x, the whole thing squared, times 2. How many guys honestly have this as your derivative? Okay, nice. That has got to be worth at least 1 point. What you need though, right, you found the derivative because you need f prime of square root of 3 over 4. So negative 1 square root 1 minus 2 square root of 3 over 4 squared times 2. And I'm feeling kind because I want you guys to get some more practice. Let's assume that we're on the free response.
Stop right there.
If we're on free response, this is done. This is slope. I'm not interested in your showing off being like, but square root of 3 over 4 is really 3 over 16. I don't care.
Yes.
Is this all a number?
Yes.
That's what I care about. So stop. Stop showing off. Uh-oh, wait a second. Parentheses there. I knew something was wrong. I could feel it. Okay, equation of the tangent line, then L of x equals, take your slope, take this nastiness, negative 2 over square root 1 minus 2 times the square root of 3 over 4 squared. That's my slope. Times x minus square root of 3 over 4 plus pi over 6. Anybody actually get this as their equation? Nice. Kind of getting there. How are we feeling in terms of comfort level with these derivatives? Pretty good? Really? As long as you, I just need you to like commit into your brain, derivative of arc tangent of x is 1 over x squared plus 1. Derivative of arc sine, 1 over the square root of 1 minus x squared. And derivative of arc cosine is the negative of that. Now, you might be thinking, but what about the derivative of arc secant? Or arc cosecant? Or arc cotangent? These things all exist and they are beautiful, and I would be more than happy to work through one of them if anybody's interested. But for all the other friends who are just like, no coach, I'm full, please leave me alone. What I want you guys to try to do in the last couple minutes is 1, 2, and 3 on page 6. There are 3 multiple choice questions. Is anybody interested in coming up with the proof of derivative of arc secant? That's okay, fine. Work on the multiple choice question.
Can we find a derivative of Brandon's hairline?
Can I find the derivative of Brandon's hairline?
You see that cusp point? Has a
concave down.
Vertical, yeah, concave vertical asymptote right there.
And this is Carlos. Wave to your mom. I'm going to show it to her. Yeah, she's so proud right now.
Show Brandon's hairline. There we go.
And this is what we're talking about. See the cusp point? There it is. It's right there. All right, everybody's getting back to work on the multiple choice questions, and I'm going to set the camera over here so that if anybody's off task, I can just show the film to like Miss Israel and your mama. Did what? For those of you in the witness protection program,
Wait, bye. Show your face clearly.
we'll block it out. I would love to.
Oh, you go to USC too?
You go to Highly, man. You go to Joshua. I said earlier.
Yeah.
6 problems.
Yep.
No, like number 2, 3, 4, and 5.
Well, that's
Page 4 and 5, you don't want to do number 1.
Have you did?
Yes.
Oh, right there. We'll switch. I forgot.
That's the first multiple choice question. If you look at their answers, they are so ready. You not really know. Right, the kid, he's like, oh, it's 3x plus 1 in the denominator, and then 3 in the numerator. They're ready for that. Now, which answer is this?
That's your
Is that either higher?
wrong pass. I don't know.
You're done with the calculus, you found the derivative. It's just a matter of Like, why would somebody pick 3? I'm thinking they would say T if they're forgetting to square 3.
Oh, yeah.
Right? They put the 3 there, like, oh, chain rule. And friends over here. No, I'm curious why. What's the mistake that somebody would make that would get them to pick A?
I got D.
Oh.
So maybe they're simplifying, but I think why would they pick this one? What do they forget? They forget about cheating. No. Right, A is the wrong answer. But the reason somebody would pick
How
A
you gonna get out of it?
is they're not forgetting
Okay,
about cheating.
times 3.
Did you square?
There, so that's 3 is on top.
Sorry.
1 plus 3x
A
squared
number
is
1 part.
9.
Why would they pick
So 3 over 1 plus 9x squared is answer choice.
Forget about the square.
Which one were you choosing?
And that's the thing. Multiple choice tests, they're not going to necessarily hit you with like crazy hard stuff, but they are ready for all the mistakes. Now I think C makes no sense. I have no idea.
Hey guys, listen up. Your homework is page 4 and 5. You don't have to do number 1. So you're doing 6 problems.